Okay, next up is question 2. It says in part A, plot the points r theta, which is equal to 4 comma 5 pi over 3, and r theta is equal to 4 comma 11 pi over 3. What do you notice? And then how about these 2 points here? Okay, so starting with these first 2 points. To plot 4 comma 5 pi over 3, as we discussed in the last video, we'll go ahead and first rotate through this angle 5 pi over 3. And then since r is positive, we're going to move outward along this ray 4 units in the quadrant 4, and that puts us at this green dot. And so here is the location of the point 4 comma 5 pi over 3. Now for the second point, we're going to rotate through an angle of 11 pi over 3, and notice that 11 pi over 3 is, well, 2 pi radians, that's 6 pi over 3 radians, and then to get to 11 pi over 3, we need to rotate through another 5 pi over 3 radians. So we go ahead and rotate through that angle, and we notice, right, that we wind up along this same ray. In other words, this angle 5 pi over 3 and this angle 11 pi over 3 are what we call coterminal angles. And since the r value is the same for these 2 points, okay, we again move 4 units out along this ray in the quadrant 4. And so in fact, these 2 descriptions are for the same location. Alright, now looking at the next set of points, r theta is 2 comma 7 pi over 6, and then r theta is negative 2 comma pi over 6. So to plot 2 comma 7 pi over 6, rotate through this angle, that's 1 1/6 pi, so that puts us down here into quadrant 3, and then we're going to, since r is positive 2 here, move 2 units out along this ray, and that puts us at this green dot. Alright, now for negative 2 comma pi over 6, we're going to rotate through this angle pi over 6, and if r were positive 2, we'd move 2 units out along this ray into quadrant 1, but since r is negative 2, as we discussed in the last video, we're then going to move 2 units out along this ray, right, in the polar opposite direction. And again, right, that puts us at the same location as this green dot. Okay, so now looking at question 2, part B, it says true or false, the polar description of a point is unique. Well, really the big point of this whole problem is to show that this is in fact false. Right? Due to the periodic nature of how we measure angles in standard form, we can see that we can represent the same location in more than one way. In fact, I could, right, consider other coterminal angles by just adding or subtracting 2 pi from either one of these angles. Okay, and if I don't change the value of r, I'm going to get the same location just described by different polar coordinates. And then likewise here for this second pair of points. Alright, cool. And now for question 3, this really is something we already did back in the last video, but just as a nice recap here, it says if a point P has polar coordinates r comma theta and Cartesian coordinates x comma y, then x is equal to, well, that was r cosine theta, y, that's r sine theta, and then x squared plus y squared, that was r squared, and tan theta is equal to y divided by x, provided x is not 0. Alright, well that's going to do it for this video. I'll see you in the next one.